I'm Brandon Sarrels, and here at Sac State, part of the Lucero group, we're going to do a palladium-catalyzed Heck reaction. This is a reaction that we have done in the past 3 years. It's been very successful for us. We've used it to make 2 target molecules. And today, we thought it was a good idea to record me running this reaction so you guys can look at the technique on how to do air-sensitive chemistry. The purpose of this video is for new students. Even if you're not going to run this reaction, you can look at the technique, look at the details, the Schlenk technique, and use it to run your own reactions in the future. So step 1 for this Heck reaction is I'm going to prepare the solvent. So for this reaction, the Heck reaction is sensitive to air and moisture. What we're going to do is prep the solvent. We're going to degas the solvent. I'm going to demonstrate that method in a little bit. There are 2 methods for degassing solvent. One method is called sparging or purging. That's the method we're going to do today. The second method is freeze pump thaw. In my experience, we don't need to do freeze pump thaw, even though it is a little bit more methodical. But quickly, just sparging our solvent is good enough for this reaction. So if we come over here in the hood, I have a Schlenk tube that's set up, and this is where we're going to purge our solvent. I'm going to open it up under vacuum. And then I'm going to turn it over to nitrogen in just a second. I'm going to turn it over slowly. Let it fill up with inert gas. And today, I'm just going to need about 10 mils of DMF. DMF is the solvent. DMF, I have it clamped up. We're going to need about 10 mils of solvent. The first thing I'm going to do is purge out my needle. I'm going to stick it in this Schlenk tube. That's under nitrogen gas. I'm going to pull up some nitrogen air and just purge this needle twice. Once. Twice.
Why do you do that?
I don't want to introduce air into this, and honestly, it's by habit. It's by habit. Just not allowing any air that would be in this needle to be ejected into the flask. Okay. We have a Sure Seal bottle of DMF. Again, I need about 10 mils. It doesn't need to be exact. Going to double dip. I'm going to draw some nitrogen into the headspace of the syringe, so when I take it out, it doesn't drip. And nice and carefully transfer it to my Schlenk tube. I'm going to get about 5 more mils of solvent. So again, I only need to purge the needle once. After that initial purge, it's good to go. And again, I'm going to draw a little bit of inert gas into the headspace so it doesn't drip and take it out. It's important that you sparge your solvent first before anything else in this reaction, because it takes about 30 minutes, so you want to get this out of the way. I'm going to take this needle, and instead of just leaving it on the bench top where it might poke someone, I just put it in these rubber quartz. Okay, so now we're going to start sparging or purging our solvent. Again, it takes about 30 minutes. What I've done is I've hooked up a long needle to this tube, and I'm going to forcefully pass nitrogen through my solvent. I'm going to demonstrate that in a second. The purpose of purging your solvent, you're degassing it, so you're taking out any dissolved oxygen in the solvent or any type of volatiles that might be in your solvent. Now, close off the Schlenk tube, nitrogen, open up this one, nitrogen, and I'm going to increase nitrogen pressure a little bit. I have an exit bubbler here. I'm going to use. And you can see nitrogen gas is coming out of my exit bubbler. It's being introduced through this long needle, and it's coming out through this exit bubbler. Now with the positive pressure of nitrogen, I'm going to take this long needle and stick it down into the solvent. It's pretty forceful, and it should look pretty forceful because you're trying to push out any oxygen that's in the solvent. And again, this will go for about 30 minutes. Okay. Okay, so I want to demonstrate kind of where the nitrogen flow is where is it coming from and where is it going. If we look at our Schlenk line here, we have two different tubes. In front we have nitrogen and back we have vacuum. The nitrogen is coming in through this front line, coming down here. We've color coded it in red so we can follow these tubes. It's going through red, down this long needle, bubbling through our DMF solvent and going out of this external exit bubbler. Okay, so now that we have our solvent, it's being prepared, it's being sparged for about 30 minutes, we can weigh out some solids and add it to the reaction flask. Here's just another Schlenk tube. We're going to add our solids into this flask. To start by taking a folded weighing paper, and I'm going to weigh out my base. What I'm also going to do is a cool little trick. I'm going to take another piece of weighing paper, I'm going to cut it off, cut off one of these corners, and fold it up into a cone so I can easily add my solids into this Schlenk tube. Just going to fold it up. Once you kind of get it folded up, you have the freedom to kind of manipulate it. And this is a lot better than using a frosted funnel or any type of glass funnel, because nothing sticks to the weighing paper. And the tube is a pretty long drop, so this is how you should add solids to your tube. I'm going to weigh out the base. We need a pretty good amount of base today.
What's your base?
It's a carbonate base, potassium carbonate. The typical bases for this reaction are carbonate bases like cesium carbonate, sodium. You can also use amine bases, liquid bases like triethylamine. But carbonate bases work well for us. Let me talk a little bit about my technique on the scale. I have both doors open. I'm leaning over, I'm supporting myself on the bench right here. And I'm holding up my reagent container, putting it through the doors, and so I can easily scoop it rather than weighing it right here. You tend to drop some on the scale. Okay. I'm going to shut the doors, find an actual mass, and record that in my notebook. I'll carefully add this to the reaction flask. We're going to add one more solid today, and that will be the plating catalyst. Unfortunately, here at Sac State, we don't have a glove box, so I'm going to weigh this out pretty fast, as fast as I can, and then I'll put the flask under vacuum in the hood. Our platinum catalyst is in this desiccator, and we're going to be using bis triphenylphosphine platinum 2 dichloride as our catalyst. Again, these are a little bit sensitive to air, so I don't want to leave this uncapped for too long. And I'm going to use the same technique that I used for the base. I'm gonna cap this nice and tight and add my catalyst to the tube. Perfect. Okay, we can cut here. Okay, so let's take a look at how our hood is looking right now. We still have our solvent that's degassing. It still needs to be degassed for 30 minutes. We've weighed out our solids, added them into the Schlenk tube. This will be where the reaction will be run. And then over here on the right, we have the Aryl bromide, also in a round bottom flask under nitrogen. Now what I want to do is cycle the reaction flask onto the Schlenk line. I'm going to do that with 3 cycles. So first, making sure that my reaction flask is sealed up, my stopcock is closed. I'm going to evacuate the tubing first. I'm going to turn this to vacuum and evacuate the tubing for about 10 seconds. Now that the tubing is evacuated and all the air is removed, I will open it up to the reactant flask and you'll hear the pump kind of gurgle. You can hear the pump, and now my plating catalyst is under vacuum. It's no longer in contact with air. So it's in my head, I'm thinking that my catalyst is a little bit safer under vacuum. I'll evacuate it for about a minute, and then I'm going to cycle the flask 3 times with nitrogen vacuum, nitrogen vacuum, nitrogen vacuum 3 times. One important thing before I turn this over to nitrogen is I want to pull up the long needle out of the solvent. I don't want to pull DMF up into my needle and into my Schlenk line. So I'm just going to pull it above the liquid line. And now I'm okay to turn this over to nitrogen. I'm turning it over very carefully. I don't want to suck too much air into my line. And that is the first cycle. I'm going to do that 3 times. Okay, so I'm about to complete my last cycle of my reaction flask. Currently under vacuum. I'm going to complete my last cycle and turn it over slowly to nitrogen. Okay, now I've cycled my flask on to nitrogen 3 times, and I can resume the purging. I'm going to increase the pressure a little bit. So at this point, I've got my flask with my solid cycled on 3 times, and if you need to purge your solvent any longer, for about 20-30 minutes, you can resume that now. At this point, I think my solvent is good to go, and so you can watch. I'm going to pull up the long needle again above the liquid line. I'm going to remove the exit bubbler, the external bubbler. lastly, I'm going to open the stop pot to nitrogen. And then I can remove the red long needle.
So you close it off first before you remove it.
Because I don't want nitrogen missing out. Okay. So my solvent is sufficiently degassed. It's in the Schlenk tube, open up to nitrogen. It's always open to nitrogen. And I also have my reaction flask open to nitrogen. The next thing to do is to get the palladium catalyst in solution. This is important because you want your palladium and your ligand to get into solution in case they have to find each other for the reaction. Just like before, I'm going to purge out my needle. This is a new needle I just got from the oven. I'm going to purge the needle twice, just like before. And so for this reaction, I need about 6 to 7 mils of solvent. I don't want to use all of my solvent. I'm going to use just enough to get this suspended in solution. About maybe 2 to 3 mils of DMF to get my solid suspended. Got a long enough needle. I've got about 3 mils of DMF. That's perfect. Just like before, I'm going to draw some nitrogen into the headspace so I can carefully, without dripping, add some solvent to my reaction flask. I don't need this syringe for a little bit, so I'm going to poke it into a rubber stopper. And then get this stirring, get it suspended. And this will stir until all the reagents have been added. Okay. Okay. Now that we got our solids in solution, we've degassed the DMF, we're going to start adding the rest of the reagents. First, we're going to add the Alkene. So I have this little round bottom flask under vacuum. I'm going to carefully turn it over to nitrogen. And I'm going to introduce the methyl acrylate, the Alkene, to this small round bottom flask. Let's open this up. Today I need about 1.27 mils. The methyl acrylate is really stinky, it's not very good for you, so we're going to do this part in the fume hood. What I'm going to do is I'm going to take this syringe and invert it. I'm going to try to get this air bubble out as best I can. So I can correctly weigh out 1.27. I'm going to syringe it into this round bottom flask. I do want to call attention to a little aspect. So I've added 1.27 mils to this round bottom flask. There's a little bit of extra liquid that's in the syringe. You do not want to put this liquid into your round bottom. This is going to be excess. It's due to the dead space that's in the needle. So you don't want to add this to your round bottom. Put this in a cork. And then put away the stinky methyl acrylate. Now I'm going to dilute the methyl acrylate in a little bit of DMF so I can transfer it easier. If you recall, I need 6.5 mils of DMF for this reaction. So I'm probably going to dilute the methyl acrylate in about 1 mil of solvent. I'm going to give this little round bottom a quick little shake. And that will allow me to transfer to the reaction flask a little bit easier. Just a little shake. Make sure it's in solution. Okay. And now we can transfer it to the reaction flask. Try your best to get all of it, and if you don't, you can always come back and wash it again. I'm going to come back and see if I can get any remaining alkene that's left in the round bottom. Try to be thorough, have good technique. That looks pretty good. This time, I want to get all this liquid out of the needle. Okay. Only one more reagent left to go. Okay, so now we have one more reagent to add, the most important reagent, which is our Aryl bromide, or Aryl halide. Again, just like the alkene, I'm going to dilute it in a little bit of DMF to help in the transfer process and add it to my reaction flask. This is a new syringe. Just like before, I'm going to purge it twice with nitrogen. I'm going to draw about 2.5 mils of DMF. Just like before, I'm going to draw inert gas into the headspace and transfer to the Aryl bromide round bottom. Put this in solution. And I'm going to demonstrate a technique that I like to use to transfer my Aryl bromide to the reaction flask. I'm going to shake this up a little bit. And I'm going to transfer the Aryl halide solution into my reaction using a long double-sided cannula needle. To do that, I'm going to poke it into this round bottom. And I'm going to allow the needle to purge gas. So now gas is going through here and coming out my cannula needle. Do that for a little bit. Before adding it to my reaction flask. I'm going to take a bleed needle and open this flask up. And then close off the Schlenk bottom. So now we can follow the nitrogen flow. Nitrogen is coming through this tube with this yellow tape. We're in my round bottom flask with my Aryl halide solution. Nitrogen flowing to my reaction flask and then out this bleed needle. And we're going to use just positive pressure of nitrogen to move this solution into our reaction flask. Now that things are set up, I can slowly lower this needle, the cannula needle, below the liquid level. Turn up the nitrogen a little bit. And you can watch as it slowly drips into the reaction. So now that almost all of my Aryl bromide solution is added, I'm going to try to get the last few drops over. I think what I will do is I'm going to wash this out, add some more DMF to this flask, and try to transfer some more reagent. I'm just adding another half mil of DMF solvent so I can try to wash this out. There's still some leftover reagent. Always just try your best. You'll never get all of it. I'm going to lower the cannula back down. Try to get all of my Aryl bromide into the flask. If you find that your solution's not coming over, you might have to increase the nitrogen pressure, or just double check your lines. Maybe you forgot an exit needle. Okay. Looks like pretty much all of my solution is transferred. Now watch closely. I'm going to work backwards to remove the exit needle, the bleed needle. I'm going to make sure nothing's in solution. I don't want anything to drip on me, especially if I was working with a more harmful chemical. I'm going to open this up, nitrogen, and then remove the cannula carefully. Turn off some lines that I'm not using. Now all of my reagents have been added. Okay. So now that all the reagents have been added, we're gonna heat up the reaction. And so typically you don't raise up the sash, but we're gonna raise it up so we can get a good view of the icoplate and the reaction setup. So I'm gonna raise up the sash, and we're gonna show how to operate the icoplate. This icoplate is really, really cool. It allows us to have good temperature control with this probe here. We're going to heat it up using a standard oil bath. And this icoplate also allows us to control not only temperature but time, and so we can have strict control over how long this reaction will be run for. Today we're going to run it for 24 hours at 110 degrees. So first I'm going to get the oil bath. And again, I know the sash is up, but it's just for video purposes. I like to have my Ica plate on a jack so I can very easily raise and lower it. This is the probe, the temperature probe. I'm going to stick that in the oil bath. One very important detail is you don't want your probe to be touching the glass, or you're going to get an inaccurate temperature reading. And we can come and take a look at the Ica plate. On the right, we have the RPMs, the stirring function, and on the left, I'm just going to rotate this knob to 110 degrees. That's the temperature of the reaction. And I'm also going to set up the timer for 24 hours. And hold the middle button, the timer button, and I'm going to use the right knob to find 24 hours. And what I like to do is add a few extra minutes to account for the heating period as it heats up to 110. I'm going to hit the knob one more time, and we're good to go. So I'm going to lower the sash. Before I heat up the Schlenk tube, I'm going to get this shield in place. Anytime you raise the temperature or lower the temperature, you should have the shield in place. And then all I'm going to do is start the timer and turn on the heat. So I'm going to hit the middle button to start the timer and then heat it up to 110, get the shield in place, and shut lower the sash. So at this point that the reaction is now heating, your sash should be down and you should be pretty much done tinkering with the reaction. And that's pretty much it. So that's how you run a Heck reaction here at the Lucero group at Sac State. So here at Sac State, we don't have a glove box, or all our catalysts are in desiccators. One important thing you want to do to increase the longevity of your palladium catalyst or any catalyst is just to flush it with nitrogen before putting it away. So what I got is a piece of parafilm. I'm going to open it up and just parafilm the top of it. That keeps any catalyst from kind of getting pushed out. I'm going to add a rubber septa over the top of it, and we could just do this real quick. Takes about 30 seconds. Add a nitrogen source. Open this up to nitrogen. And increase the flow rate just a little bit. I'm just going to take an exit needle so I can flush out the oxygen. And I'm just going to do this for about 30 seconds. It's a small bottle. It shouldn't take very long. So again, I have a positive pressure of nitrogen, an exit needle, and it's very quick. Now I just want to be quick when I do this. Take it off. I'm just going to screw this back on. I'm just going to parafilm this and put it back in the desiccator.